The United States military has reportedly introduced the Precision Strike Missile, PrSM, into combat operations during ongoing strikes involving Iran. This represents the first operational use of the PrSM in a real conflict, a notable milestone given that the missile only began entering U.S. Army service around 2 years ago. Admiral Brad Cooper, head of United States Central Command, confirmed this development. U.S. Central Command, CENTCOM, released a video made up of still images documenting what it described as the first 24 hours of Operation Epic Fury. Among the images included in the video was a photograph that clearly shows the launch of a precision strike missile from an M142 High Mobility Artillery Rocket System, HIMARS, mounted on a wheeled launcher. The PrSM represents the next step in the modernization of the U.S. Army's long-range precision fires capability. In this video, Defense Updates analyzes why PrSM is being deployed against Iran. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The MGM-140 Army Tactical Missile System, ATACMS, has been part of the U.S. Army's long-range strike arsenal for more than 3 decades, having entered operational service in 1991. Its combat debut occurred during Operation Desert Storm, the air-land campaign of the Gulf War. The system later remained a key component of American precision strike capabilities for decades. In more recent years, a limited number of ATACMS were transferred to Ukraine, where they have been used against high-value military targets with notable effect. Their deployment highlighted the missile's enduring relevance despite its age. However, the ATACMS design has gradually approached the limits of what modernization can achieve. Even with upgrades to guidance systems and warheads, the missile's maximum range of roughly 300 kilometers, about 190 miles, constrained its operational reach in modern battle environments, where adversaries increasingly deploy assets far beyond that distance. Recognizing these limitations, the U.S. Army initiated the Precision Strike Missile, PrSM program, to replace ATACMS and significantly expand long-range strike capabilities. In 2016, the Pentagon selected Lockheed Martin as the primary contractor responsible for designing and producing the new missile. Development progressed rapidly. The first successful flight test of the PrSM took place on December 10, 2019, at White Sands Missile Range in New Mexico, where engineers validated key aspects of the missile's propulsion system, guidance architecture, and overall aerodynamic design. Subsequent trials continued to demonstrate improvements in reliability and performance. One particularly significant milestone occurred in February 2025, when 2 PrSM missiles were launched in quick succession from a HIMARS during a test event. The successful dual launch confirmed that the system could operate at the firing tempo required for battlefield conditions and help clear the path toward full-rate production. The Precision Strike Missile, PrSM, Increment 1 is the first operational version. This initial configuration offers a maximum reach of roughly 499 kilometers, about 310 miles, and is optimized for striking land-based targets deep inside an adversary's operational zone. Physically, the missile measures approximately 13 feet, 4 meters in length, and has a diameter of about 17 inches, 430 millimeters. It is propelled by a solid-fuel rocket motor, enabling rapid acceleration and high terminal velocity. Navigation relies on a combination of inertial navigation, INS, supported by GPS guidance, allowing the missile to achieve high accuracy against distant targets. The weapon carries a 200-pound, 91-kilogram, high-explosive fragmentation warhead designed to destroy or severely damage hardened or area targets. It has a speed in excess of Mach 3. PrSM Increment 1 is intended to strike a broad spectrum of objectives, including command posts, logistics hubs, air defense sites, and other critical infrastructure. Its mission profile supports operations across multiple command levels, from brigade formations to theater-level forces, and it can be employed by joint and coalition units, including Marine Air-Ground Task Forces. The missile is designed for use in full-scale conflict, limited engagements, and expeditionary operations, providing ground forces with deep strike capability. Each missile is estimated to cost around $3.5 million, reflecting the advanced electronics and propulsion technologies integrated into the system. Like its predecessor, the PrSM is compatible with the M270 Multiple Launch Rocket System, MLRS, and the M142 High Mobility Artillery Rocket System, HIMARS. However, the newer missile features a slimmer and more aerodynamically efficient design, which significantly improves launcher capacity. While a single launch pod previously carried one ATACMS, it can now accommodate 2 PrSM rounds. This effectively doubles the firepower of existing launch systems, allowing the M270 to carry 4 missiles and the HIMARS to carry 2. The improved capacity is achieved through modern propulsion technology that provides greater range and speed without increasing the missile's physical bulk. Built for all-weather, 24-hour operations, the PrSM gives field artillery units the ability to strike targets far beyond the forward line of troops. Its open architecture design also allows the missile to be upgraded easily, enabling future variants to incorporate new sensors, payloads, and mission profiles without requiring a complete redesign. The system also addresses policy requirements that affected earlier munitions. Unlike some ATACMS variants, the PrSM is designed to comply with insensitive munition standards and U.S. cluster munition restrictions, ensuring safer storage and handling while meeting modern international policy guidelines. Future upgrades are already planned. Increment 2, sometimes referred to as the Land-Based Anti-Ship Missile, LBASM configuration, will incorporate a multi-mode seeker capable of engaging moving targets, including hostile naval vessels. Additional enhancements are planned for later versions. Increment 3 is expected to introduce new payload options designed to increase lethality, while Increment 4 aims to dramatically expand the missile's reach, potentially extending its range to more than 1,000 kilometers, around 620 miles, roughly doubling the distance achievable by the current version. The key values of PrSM are speed and range. These are critical when it comes to engaging a long-range and time-sensitive target like a ballistic missile TEL. Even if a military has the best ISR, it needs a weapon that can engage the target within minutes. PrSM can get a warhead on a target 500 kilometers away in about 8 minutes, which could take an hour for a fighter or about 35 minutes for Tomahawk land attack missile. So now, when a stealthy RQ-170 drone, satellite, or recon team identifies a target, it can be hit swiftly. The OODA, Observe, Orient, Decide, Act, loop closes fast and an enemy can be taken out before it moves. This is especially relevant against Iran, which has a large arsenal of ballistic missiles. The United States did not pursue a missile in the class of PrSM earlier, largely because of restrictions imposed by the Intermediate Range Nuclear Forces Treaty, INF Treaty. This landmark arms control agreement was signed in 1987 by Ronald Reagan of the United States and Mikhail Gorbachev of the Soviet Union. Under its terms, both countries agreed to eliminate ground-launched ballistic and cruise missiles with ranges between 500 and 5,500 kilometers, roughly 310 to 3,420 miles. The strategic environment began to shift decades later. On August 2, 2019, the United States formally withdrew from the INF Treaty, arguing that Russia had not adhered to the agreement. Washington stated that Moscow had deployed missiles that exceeded the treaty's permitted range limits, particularly the 9M7-29 Novator cruise missile, which U.S. officials said violated the treaty's provisions. Another factor influencing the decision was the growing missile inventory of China. Beijing was never a participant in the INF agreement and therefore faced no restrictions on developing ground-launched intermediate-range systems. Estimates suggest that China's People's Liberation Army Rocket Force operates more than 2,500 ballistic and cruise missiles. the vast majority of which fall within the range categories previously banned by the INF Treaty. Had China been a signatory, roughly 95% of these weapons would likely have been prohibited. With the treaty no longer in force, the United States gained the freedom to pursue new ground-based missile systems with greater reach. The deployment against Iran shows that it's fully combat ready,